And welcome everybody to the Daily Space Weather. Lots more exciting stuff to talk about once again today in space. Here's the closest star for all you stargazers out there. It's El Sol. Shout out to the sun. We've got some activity going on here, and it's nothing like the activity was 22 years ago. We'll talk about that momentarily as well as things like the Hale cycle and more. Major sunspot groups down in the southwest. The likelihood of major flares from those major sunspot groups going up as they approach the southwestern limb. A sunspot setting in the northwest. This is the colorized magnetogram. It shows you South Pole magnetism in red, North Pole magnetism in green and blue, yellow and red for south. And actually, you can see this sunspot here, the umbrae are actually closing in on each other, which is a recipe for them to cancel each other out and shrink the sunspots. So that actually lowers the likelihood of solar flares, in my opinion. Here's the 193 angstroms view, and I would note one thing here. There is a massive filament right in this area. You can kind of see it in this wavelength. We'll show you it better in 304 angstroms later in the video. Also, check out the North Pole coronal hole. Very well defined at the moment. Not migrating really at all, as cycle 25 continues to take its good old time progressing. Here's a close-up of those sunspots in the southwest. This is a composite view in ionized helium and ionized iron. The ultraviolet emissions from those chemicals. Just a fantastic close-up there. And as always, we'll have more spectacular imagery for you. Let's take a look at Lagrange point 5, the location of stereo A, as we saw a coronal mass ejection yesterday. Yeah, and I forecasted it. If you remember yesterday, I said coronal mass ejection warning for the far side of the sun. And there you can see one. There was actually another one since then in the same location. So we still have a coronal mass ejection watch on the Earth side of the sun and a coronal mass ejection warning on the far side of the sun. We'll be keeping a close watch on that. The radio flux has actually dropped down to 96. And for you new viewers, congratulations on finding our channel. The radio flux is emitted from the upper chromosphere and the lower corona. Just this small portion of the outer surface of the sun, or you could say the lower atmosphere. It's down to 96. It's the most proportional number we have in terms of data that's telling us what solar activity is like. You can see the sunspot number actually crossed over the radio flux here. And you can see how proportional the radio flux and the sunspot number is. The radio flux is the black number, and the red line is the sunspot number. So here's a space weather enthusiast dashboard. We did see geomagnetic unrest briefly from a weak coronal hole wind stream, which is already subsiding. Not a lot of fireworks from that. It was mainly caused by a negative BZ component and the initial shock wave of density. We'll show you the real-time solar wind. First, seismicity. Here's the year to date. And here's the last 90 days of earthquake activity. Current conditions are moderate. We saw some come in just a little while ago here. We're just going to scroll up the list. No major quakes here, nothing higher than a 6 magnitude. South Sandwich Islands re-intensifying here with a 5.5, and some of the most recent quakes were in that area as well. The most seismically active portion of the planet right now, near the tri-plate boundary of the Antarctic and South Atlantic and South Pacific plates. So several quakes in the 5 range, nothing in the 6 range. One of those South Sandwich Islands quakes was at depth, that one 105 kilometers estimated depth. And here's a deep one coming in right as we start recording the show here. A 4.8 at Timor-Leste at over 530 kilometers estimated depth. Little uptick in volcanic activity here. Popocatépetl back on the list, and it remains on my bucket list. Karimsky, producing a volcanic ash eruption here on the Kamchatka Peninsula. No idea what the flight level or altitude of that is. Suminose Jima, Flight level 080 there. It's an 8,000-foot ash plume. Langila. Now on the list, exploding. 8,000-foot ash plume over Papua New Guinea's Isle of New Britain. Popocatépetl, exploding. 20,000-foot ash plume over central Mexico. Fuego dispersed its ash. That located in Guatemala. Sangay in Ecuador has dispersed its ash as well. Revenador still exploding in Ecuador, though. 15,000-foot ash plume over that Central American nation. South American nation. Sabancaya exploding. 24,000-foot ash plume over Peru. Please do not pole vault the caldera. Please do visit our links. You can find links below the videos to our Red Bubble shop. Perhaps pick up some Do Not Pole Vault the Caldera merch. There's like over 50 products with the design, and the print quality is, shall we say, awfully high. I do have a pair of the Do Not Pole Vault the Caldera socks. In fact, I think I have two, and Smash Staff has a pair. And going back to space here to look at the GOES magnetometers over the past 3 days. Those arc-jet moments are where the spacecraft turn on their thrusters, and they create plasma which can affect the magnetometer measurements. These are geosynchronous orbits located around the equatorial region of the planet at about 6.6 Earth radii. We saw some high readings here as that plasma pressure wave came in from that weak coronal hole wind stream late last night. Since then, some low readings showing up. And for you new viewers, the M's and N's stand for midnight and noon local time for the satellites. Let's take a look at the ecliptic plane field plot here. The polarity of the heliospheric current sheet, and we expect Earth to remain in a North Pole current sheet for the foreseeable future. This data just about an hour old when we recorded the video. We'll also show you a line-of-sight view of the same data, rotating the things 90 degrees here, looking at it from Earth's perspective instead of from the ecliptic plane perspective. And you can see the solar magnetogram, most of the activity in the west of the sun right now. There is a new sunspot slated to rise over the east as well. We're not worried about that. There's too much going on the Earth-facing portion. So here's your coronal hole plot. And you can see a trans-equatorial coronal hole just moving in past the Earth-facing zone here. Not particularly well defined, and not a lot of migration from the North Pole yet. We're going to show you what's going on. Now, this is the LASCO C3. This is located at Lagrangian point 1, right here where my pointer is. About 1 million miles toward the sun between the Earth and the sun at a gravitational equilibrium point that allows spacecraft to remain there and measure things like the solar wind. So this data here is from Lagrange point 1. This is the LASCO C3 coronagraph. And this, if you look at the time and date stamps in the lower left, this is from 1999, exactly 22 years ago. So this is 11 days of data at the last Hale cycle, at this same point approximately in the Hale cycle, as the sun's solar polar field reversal cycles take 11 years, and for the full reversal to happen, they take 22 years. I think that's the planet Mercury there swinging behind the coronagraph. And you can see how much activity, how much plasma is being blasted out of the sun here back in 1999. Just to show you how less active the sun is at the moment, here's where things were in the past 11 days. So you can see how much less activity was going on here. This is 9/1 through 9/11/2021. And you can see how little plasma the sun is putting out during this solar cycle. Almost nothing compared to 22 years ago. You can look up this data yourself. It's part of the Soho movie theater. If you just type in Soho movie theater in your favorite search engine, you'll find that. There's a coronal mass ejection from the 6th. And we did have coronal mass ejection warnings up. We just recently exhausted those. We lowered them to coronal mass ejection watches. Although, again, there is a warning for the far side. So, again, here's what it looked like in 1999 at around this point in the last Hale cycle. which is the full solar polar field reversal cycle. And here's what things looked like this month, September of 2021. I would say it's a little bit less activity. What do you think? Leave us a comment. It's sort of a rhetorical question. Anyway, if you want to read more about solar cycles, check out the wiki article. It's not bad. And what we're talking about here is the Hale cycle. So the Hale cycle, elucidated by George Ellery Hale and collaborators, who in 1908 showed that sunspots were strongly magnetized, the first detection of magnetic fields beyond the Earth. In 1919, they showed the magnetic polarity of sunspot pairs. So anyway, lots of information on the wiki article if you want to read about sunspot cycles. We did talk about the butterfly diagram yesterday. Watch yesterday's daily space weather video if you'd like to hear about the butterfly diagram. The latitude of sunspots and their tie-in to progression of solar cycles. Part of our mission is to explain the solar cycles. As believe it or not, I believe I've explained the mechanism that underlies them. We won't go into it in this video, but we will talk briefly about our mission. You can read about it at smAshtember.com/forum/mission. Number 1 is to assist, study, and report on the ongoing formation of a unified theory of physics. And number 7 is to not be ossified in our beliefs and to treat those who are with love, respect, and inclusion to the scientific discussion. You can read a lot more about that at our forum, and you can read a lot more about cosmology and heliophysics at our forum, smAshtember.com/forum. You can find links to all of our stuff at the homepage, smAshtember.com. Perhaps check out the Sun forum. And I would highly recommend reading about the liquid metallic hydrogen solar model, as well as the grand solar minimum thread. You might learn something you had no idea about. smAshtember.com. You can find links to all of that there. And thanks to our SMASH team for making it even more possible for our operations to continue to expand. So here's our solar flare monitor. And you can see the probability very high. Solar flare warning remains in effect. And if these sunspots remain stable, which it doesn't look like this one is actually, it looks like it's breaking down, but if these remain stable as they get closer to the limb, the likelihood of producing major flares actually goes up. Why? Because the sun seems to emit photons like a metal. I don't know what else to tell you besides that's what the observations tell us. That's what they elucidate about what the sun is made of. So high likelihood of solar flares. Let's continue on here. We don't want the video to be too long. The GOES X-ray flux over the past 3 days showing some only minor intensifications. A couple of C-class flares here over the past 48 hours. No spikes in the proton flux, no coronal mass ejections forecasted by our channel, and none headed our way. Here comes a real-time solar wind. And the KP4 geomagnetic unrest conditions were caused by this moment right here. So we had a strong negative BZ component, which is this red line. And as the density wave subsided, we saw an increase in the solar wind velocity, a decrease in the solar wind density, and a shift in the BZ back into the positive territory. That's why the geomagnetic unrest ended so quickly. It was just a transitional moment here when the solar wind, when the coronal hole high-speed wind showed up in earnest as a steady wind signal. The BZ shifted back into positive territory, reducing the geo-affect of the incoming solar protons. Current conditions are about 7.5 protons per cubic centimeter for the solar wind density. Solar wind speed quite low once again to 321 kilometers per second. Very slow background style solar wind speeds with all the low levels of activity we've been seeing, as we showed earlier. So the KP index is a measurement of global geomagnetism, and we're currently only at a KP of 2. You can see that brief period of 3 hours or so of geomagnetic unrest just before midnight last night on the 10th. Here's the geospace over the past 4 hours, modeled by the Space Weather Modeling Framework. It's magnetohydrodynamic pressure modeled in nanopascals. Things looking pretty homogeneous. We can expect a little subsiding of the pressure here with such a low solar wind speed. And indeed, we do see a little subsiding of the magnetohydrodynamic pressure to go along with that. No surprise to our regular viewers. Next, ground magnetic perturbations modeled in nanotesla magnetic flux density. We do see some significant magnetic perturbations here, more so in the northern hemisphere than the south, and we show this data daily as well. It's 4 hours, just like the last pane, and since we're currently living a geomagnetic excursion, we like to show it daily to see where the current perturbations are. The geospace delta B changes to Earth's B field, the field that goes through a magnet. Here's a diagram of the solar system. And no, planetary alignments do not affect solar activity. Solar activity affects things in the solar system. Things in the solar system don't affect solar activity. We've watched it over and over again, and people keep claiming that it's true. And every time it doesn't happen, they mysteriously go away for several months until a planetary alignment happens again, and then they come back and they say, hey, planetary alignments. And that absolutely doesn't change the opinions of any real astronomers because, well, we don't see it sussed out in the data. Let's advance this 1 week. There's where things will be in a week. No, sorry, folks, everything's not electric. Everything is not connected. Continuing on, I know that's pretty controversial in this day and age with so much science nonsense believed by so many people. Here's a star chart. We've drawn in the ecliptic, which is the yellow line, and the galactic plane, which is the blue line. It's in-the-sky.org. And let's do a brief cosmology segment, once again integrated into the Daily Space Weather video. It's a value-added service. Let's talk about Sagittarius A star, the massive radio source at the core of the Milky Way galaxy. Wondering what it looks like? Well, it looks something like that. It's the point shown here in blue around which all of these massive blue supergiant stars are located. Sagittarius A star, the massive radio source at the core of the Milky Way galaxy. It's been in the news because there have been some odd radio emissions coming out of the area. I think they're caused by a plasma structure. And keep in mind, as these massive stars orbit this massive radio source, they're causing huge effects on the plasma structure. Now you can see this is many, many years of modeling here because these stars that orbit in these close, extremely eccentric orbits around Sagittarius A star are certainly affecting all kinds of things like plasma structures, magnetic field environments, X-ray outputs, all sort of effects on the environment in this very, very busy area. Anyway, here are the hard X-rays from that region. And we're going to take a look at this in visible and some other wavelengths here. So let's go to the CDS portal. And here's what the area looks like in optical. So this is the pan-stars, and it's a pretty dusty area, folks. It's very hot. There's a lot of radiation. And all we see in optical is this tiny little structure here. Meanwhile, you can see a lot of very hot, very large blue stars all around the area. Some of these are orbiting at relativistic speeds consistent with the solar wind speed, hundreds of kilometers per second. Here's what's going on in heat. So as you can see, the galactic core region is a very hot zone. So there it is in infrared light. And we'll also show you the X-ray spectra real quick. There are the hard X-rays from the area, and you can see some structure there in the X-rays coming from the core of the Milky Way galaxy. Anyway, that's it. Sagittarius A star. Here's the astronomy picture of the day. You can find it yourself at apod.nasa.gov. There's a great link to this as well. If you check out this Saturn at night picture from the Cassini, which is quite a spacecraft indeed, there is a link right here. And if you click on one of these links, the grand final plunge, it'll send you to this page here. So go to apod.nasa.gov and check out this page. It's absolutely spectacular. It's the page about the final plunge. Cassini made multiple, I think 22 orbits inside of Saturn's rings. And it is absolutely spectacular, the imagery that it received. It also received all kinds of data about Saturn's upper atmosphere, the ionosphere, and all kinds of other stuff that was not known before. Cassini, one of the most incredible spacecraft ever, and having returned some of the most incredible imagery ever taken of Saturn, some of which is from inside the rings. Absolutely spectacular. That's today's cosmology segment. Let's hurry up with the rest of the daily space weather video. And don't forget to check our playlists for over 200 additional cosmology segments at youtube.com/smAsho/playlists. All right, we've got more data to blast through, including charging hazards. We don't see any at the moment. Let's take a look at electron flux. Here's the relativistic electrons at the F ionosphere layer over the past year, as reported by Solon.info. We're just at moderate levels here. Here's a 3-day chart. We never saw warning levels yesterday. Let's check the forecast. Forecast is for flat levels of electron flux. The green boxes are the forecast. The yellow diamonds are the observations. Next, we're going to look at the total electron content through the entire air column up to a GPS satellite, which are orbiting at tens of thousands of miles of altitude. Here's the total electron content forecast. It'll show you likelihood of GPS errors, which mostly occur around the equator at noon. And we see some chaos here in the electron density. You're going to see some surprisingly high electron flux regions here, mainly over Southeast Asia. And you can expect some massive GPS errors when you start to see this thing turn orange. And you can even expect GPS errors when you see it turn yellow. It gives you insight into where they'll occur. It's the total electron content forecast. And there are other zoomed in versions of that also, by the way. Here's a diagram of the atmosphere to show you where the F ionosphere layer is, because that's next. And here's the ionospheric map. The last day in vibrational frequency. Each color blob represents 1 megahertz or 1 million vibrations per second. And everything looking fairly smooth here. Some high frequency anomalies showing up here around South America, especially. And we'll show you the anomaly map next. Here's the latest image. That's from 10:30 Universal Time. Here's the anomaly map. Departure from the 30-day median in megahertz. Departure from the 30-day median in megahertz. And you can see some quite significant high-frequency anomalies on both sides of South America. We'll make sure that plays through a second time there. Some significant high-frequency anomalies, folks. Over the south-central Atlantic. Also northern South America. Anyway, here's the latest image. That's 10:30 Universal Time. Some low-frequency anomalies over North Africa, and some high-frequency anomalies over places like the West Pacific. So there's the 10:30 image in ionogram. There's the 10:30 image in anomaly map. All right, and here come our bonus features in the form of the El Teide, Spain, ground-based solar observatory. You can see this massive filament in the northern hemisphere, as well as sunspots setting over here. Check out this filament. It's quite visible here as a dark region there. That's the part of the source of our coronal mass ejection watch. Far side coronal mass ejection warning. Solar flare warning, big time, remains in effect because of these sunspot groups down here. We're also seeing sunspots at 2 different latitudes. We're seeing them down here as well as up here, an indication that solar cycle 25 may not be as weak as some alarmist hack frauds on YouTube would prefer you to believe. Here's the latest refresh of the solar intensity gram, and you can see indeed this sunspot is starting to degrade a bit. This one's still remaining pretty strong. This one down here is still beta class, and this one up here is going to set today and lose its name. It looks like it's alpha class also. Here is the latest refresh on the magnetogram. And as these umbrae get closer together, they are likely to begin to cancel each other out. I think they're already doing it. Not likely to produce major flares as a result of umbrae getting closer together. We think umbrae spreading apart is what makes large flares more likely. But in any case, here is a close-up in 131 angstroms of the area. Absolutely spectacular imagery once again from the Solar Dynamics Observatory. Here's 1600 and 1700 angstroms. And when you see bright spots here, that's likely carbon being produced through nuclear fusion right there before your very eyes on the surface of the sun, right out in the open. Is it happening in the cores of stars, or is it only happening on the surface of stars? I won't conjecture in this daily space weather video. We don't want it to be too long or too controversial. But that's some extreme UV light in both 1600 and 1700 angstroms composite view. And you can see the trailing umbra there is catching up to the leading umbra in this sunspot. So that's a little bit of degradation, a little bit of forecasting. Here's 304 angstroms, full disk view, a great view of this large filament. Just to recap, solar flare warning still in effect. Coronal mass ejection watch for the Earth side still in effect. Coronal mass ejection warning for the far side. We're just demonstrating how we're able to forecast coronal mass ejection warnings here, or moreover, that we're able to forecast coronal mass ejections. Not exactly how we're doing it, because, well, we haven't written a science paper on it yet, and we don't want to divulge that information before informing the heliophysics community about it via a science publication. When it gets submitted for peer review, we'll make a video about it. Until then, you'll have to deal with our forecasts on things like our daily space weather videos. Last but not least, here's a full disk image of the closest star in 171 angstroms, my personal favorite wavelength. It's ionized iron. And we are out. Thanks for tuning in, and may that solar wind be at your back.